This is one of the problems from welded joints. A plate of 80 mm wide and 10 mm thick is to be welded to another plate by means of parallel fillet weld. See, you can see this is the fillet weld, parallel fillet weld. The plates are subjected to a load of 50 kilonewton. This subjected to 50 kilonewton. Find the length of the weld so that the maximum stress does not exceed 50 Newton per millimeter square. That is tau. In the data I have written, that is tau, 50 newtons per millimeter square. So we have to consider here static loading and dynamic loading. So initially I have written the data that 50 kilonewton has to be converted into newtons, that is 50 into 10 to the power 3 newtons, and this is tau according to the equation I have mentioned in notations. So this equation is from 3rd edition of design data handbook. The page number is 70, equation number is 6.1. See, after this one cos 45 will be 0.707. you can use a calculator to calculate. So we'll substitute the values and later we'll get the length as 141.42 millimeter. So now we have to consider start and stop allowance. Start and stop allowance in the sense, so when we start welding, we will not exactly start from the point, but we will have some extra distance from like this here, and when we end the welding, it will not stop here, but it will go somewhat extended. It will go some point ahead. So this is the 1 point, 1 2, here also same, 3 4, these are the points. So the number of free ends, what I said is number of free ends, that is calculated as LT is equal to L plus phi I. This is not in our data handbook, but you have to remember this one. You have to add this. Okay, substitute the values and you will get this LT value as 161.42 millimeter. And later, now effective length of each weld, we have to find the effective length. So we have L value and divided by 2 for both sides, one upper side and another lower side. So we will get this point. The total length of each weld, LT value we have calculated here, total length. So the length of each weld is like 80.71. so we have to divide each weld for this upper side and for the lower side. This will be 80.71 is the length. So similarly, that was for static loading, and during the case of dynamic loading, we have to use stress concentration factor. Stress concentration factor using data handbook, we can get it from here. See, here we have one table number 6.4, type of weld and stress concentration factor. So end of the longitudinal fillet weld, we are using longitudinal fillet weld, that is why it is 2.7. so here it is 2.7, so we are using that value. And the tau dash I had mentioned, tau dash is 50, tau dash by 2.7 will give you tau value. See, I have taken tau value here. So this will be, so static is different, dynamic is different. You can use the same notations, but if you want, you can also change it. So but I have used an tau dash so that I can make you sure that the same equation has been used to this also. So this is the values which I have substituted, and the length you will get. Similar procedure will carry out, but only this will be changing. In dynamic, you have to use stress concentration factor. At that time, this point will change, this value will change, and remaining everything will be same. And the procedures also same. No changes in any procedures which you have done for static loading. Okay, thank you. And fatigue loading, if it is a fatigue loading instead of dynamic loading, if they give fatigue loading, then you can also go for the same method. There is no changes in it. There is no changes adopted in that method also. Okay, thank you.